This looks like it's going to be a hard question, and it kind of is. So here's what I would do first and foremost, just to simplify things from the start. I see that this letter A, that's the side of this hexagon, just carries through the question, right? It's a variable in the actual picture, it's a variable in the answer choices, and so I would want to get rid of it just so I have one less thing to think about while I'm doing all these crazy calculations. And in this case, I would just assume that A is equal to 2, because kind of looking ahead at my answer choices, I see that the fractions involve 2, and so I want to make it as simple as possible for myself if I have to create a fraction. So just a little forethought, but to be honest, any number will work here, especially because it's the calculator section. So once we have a number, we can do a lot of the calculations with that number in our calculator, which we can't do if we have a mysterious variable. So this is why this strategy arithmetize is so good. Now, the key here is that we need to find the value of df, which is this kind of random looking line. Here's how this goes. Whenever we have hexagons, you want to associate those strongly with the idea of 30, 60, 90 right triangles. Okay, so 30, 60, 90. And this equation, or this kind of proportion, is given to you at the beginning of the section in the reference chart. Basically, the reason these are so special is they have this very special proportion where if we know one of the sides, we're going to know all three because of the proportion. So that's what's happening here. To cut it short here, you have to kind of trust me that these are going to be 30, 60, 90 right triangles. So the 30 degrees is the smaller angle, the 60 is here, and so we can kind of match that if we know that the hypotenuse is 2. That's going to be this side here, meaning that x is going to be 1, and now we have, okay, 1 root 3 as the side that is longer opposite the 60-degree angle. So this is root 3, and then on the other side, this is also root 3, and just to make it clear, this height is 1. Now we can prove that these are 30, 60 right triangles because if you divide up a hexagon, you're going to divide it into 6 equilateral triangles, which each have then angles of 60, which then get divided into 30, 60, 90 triangles. But I'm going to save you the time. Just trust me, hexagons are 30, 60, 90 right triangles. So now that we've got this, well, we see we want the length of df. Well, that's radical 3 plus radical 3, which is 2 radical 3. If I plug in a equals 2, is that an answer? Well, it's not choice A. If we plug it into choice B, though, look, those 2's are going to cancel out. That doesn't quite get it either. But look, choice C is just 2 radical 3. That's going to be the answer. This is complicated. This is not a high priority question for most people taking the SAT. But if you're shooting for that 800, you got to be able to work with hexagons. You got to be able to work with weird shapes. And luckily, most weird shapes are just normal shapes in disguise. So 30, 60, 90 right triangles are going to be what you find when you look at hexagons.